Welcome to AI-Assisted, AI-Augmented, and Autonomous Testing, Choosing the Right Approach, presented by Applitools. I'm Tim Hines, and I'll be the session host today, and I'm joined by my colleague, Lee Vardaro, our Technical Solutions Architect. Lee brings a wealth of testing experience, having worked as a lead customer engineer, supporting over 100 QA teams across dozens of Fortune 500 companies. He's skilled in several programming languages and all of the major test automation frameworks, and he has a significant experience leveraging automation with leading device labs and commercial solutions. Here at Applitools, Lee helps new customers evaluate and set up AI end-to-end testing with Applitools Autonomous and eyes.
Thanks everyone for joining. Like Tim said, my name is Lee Vardaro. I'm a technical solutions architect here at Applitools, and today we'll be discussing, AI-assisted, AI-augmented, and autonomous testing, and a lot of the various technologies associated with it. So just quick overview of the agenda. First, we'll just talk about defining the landscape. Next, we'll go over a lot of the more common core components and technologies, talk a little bit about production readiness, and then at the end, we'll do a Q&A session. All right, so first, we have the terms AI-assisted, AI-augmented, and autonomous. What are they? So AI-assisted would be more of a assistant type solution, like maybe a coding assistant. We'll talk more about those later as well. Whereas AI augmented is a little more, AI involved. It tends to take less input. Maybe for the case of AI augmented, I give my AI access to my test case repository. It goes through it and makes suggestions on, hey, here's some test cases we think, you're missing some gaps, these would fit in there well. But it's still up to the human to make that final decision to approve them. Autonomous is more of is what we talk about. I give a bunch of inputs, obviously it needs to know some info about my application, maybe some, usage metrics, access to, maybe the Jira or my project management system, my existing test cases, but it basically fills in all the gaps, and then I tell it to start testing, and it starts testing. So these actually differ a pretty good bit from traditional testing. Traditional testing is usually a variation of, all right, we have some new requirements that came in. They've built some new features. Maybe they're in Jira, in a story or some other project management system. The QA looks at them, comes up with a test case. This is how I'm going to test this scenario. They test it. Nowadays, most people would turn around and automate that into regression tests. We want to make sure that same functionality that we just tested with this release works on the next release. Nothing new ended up breaking any of my old functionality. But that, tends to be very heavily involved with people either manually testing or, in the case of automation, spending a lot of time creating test code and maintaining that code. And then when we talk about the role of human oversight versus full automation, really, in my opinion, even with autonomous, if something were built as completely autonomous, I never need to do anything. It just works on its own. I still would want to come in and make sure that it's working correctly. I've noticed the more you rely on the AI, as in, more when you're instead of giving it step instructions, you give it very high level instructions. That's really where someone needs to come in and make sure that the AI is interpreting that correctly and not, filling in gaps by hallucinating. Some other terms I just wanted to talk about is in-house versus third-party AI. Now, there are a lot of reasons why many companies have went with third-party AI. A big one being just very quick to get off the ground and running. And when I say third-party AI, I mean, providers like ChatGPT, Claude, things like that, that, they're using their APIs to reach out and perform this processing. So it's very quick and easy to get off the ground running. The AIs are already trained. They're very smart. It's just you integrate them using their APIs and you're good to get going. On the other hand, we do have in-house. This is where we host our own models. Typically we're training them with our own data. And that actually is kind of the difference, I think, between AI engineering and prompt engineering. So AI engineering is actually working on AIs. Maybe, you can kind of lump in machine learning engineer in that same bucket, but it's actually where the engineer has a very good understanding of how the AI works under the hood, how its learning models work. They actually come in there and build it, versus prompt engineering, which is what you see, what we see a lot with people using third-party AIs. It's not they might not necessarily have any idea what the training sets were, how the AI really works under the hood. Their skill set lies in properly formatting prompts in order to get the correct response. So a lot of times that gets lumped into with the API developers, right? Because those prompts are taking place on the back end via API. So someone needs to know how to properly word the prompts and how to actually build the API that's going to communicate with that third-party AI provider. There are some things to take into consideration when doing that. Data security is a big one. With in-house AI, which is what we use for all of our AI here at Applitools, we know that the data is secure. We give you our security documents. We answer your security questionnaires. We basically, have a relationship between just, us and our customer. Everything, we can guarantee the security of all the data. When you're using third-party AI, we just don't know as much. We don't, we're giving you all of our security audits, but when you're using a third-party AI, we're just not as sure about their security. We want to make sure that they're not using your data to train their AIs, that they're securely storing everything in a manner that, you don't have to worry about somebody getting a hold of your company's data by a security breach. Also, this isn't a bullet point, but we noticed a big performance difference as well. We have a, very purpose trained AI on our side. It's really, we have our visual AI, and then our natural language processing test automation AI. And since we're using our own in-house AI for those, and we're not just using a third-party endpoint with a very large model, we see a lot of performance improvements with our AI versus someone, calling out via API to chat GPT. I also want to discuss a little bit about the cost of using these AI APIs. Right now, the providers are basically all running at a loss. You've got you're paying for tokens or blocks of data on the back end, calling those APIs, and companies like OpenAI and Anthropic are actually losing money every time you make a call. At some point, that's got to change. Now, there's everyone's trying to reduce the cost of these these tokens and to get that down, so they're actually turning a profit. But there's always a possibility they might end up having to raise prices some as well. I wouldn't be surprised to see some of both. The costs come down, but the price go up. And when that happens, if you're using if you're using a company that makes use of these AI platforms, it could end up getting that cost passed along to you. Just kind of something to keep into consideration with that. I also want to talk about deterministic versus non-deterministic AI. So deterministic AI means if I give it the same input, I'm going to get the same output every time. Non-deterministic AI is actually what the big providers we've been talking about use. And that's if I ask them to write a 20-page paper on the American Revolution, it's going to spit out a 20-page paper on the American Revolution. I can turn right back around and ask it the same question. I'll get a 20-page paper again, but they're not going to exactly match. It just basically means that at runtime, it can spit out different data just every time you give it an input. And that can have some impact on, having flaky tests when they're running. It can also just give you inconsistent results. When we're dealing with testing, a lot of times we don't want to introduce any variability that's not intentional into the test. Like we want to have variability in our data, maybe in some of our test cases, but as far as the underlying framework, we don't want it just to randomly do things that we're not expecting it to. That ends up resulting in flaky tests. And when I say flaky test, anyone in the QA industry is probably familiar with that term. It just basically means I can run a test 3 times and it passes, and then randomly the 4th time it fails for no reason. And that ends up just causing a lot of extra effort rerunning tests, debugging tests, and trying to determine failures. Also, just want to talk about the rapid change of AI. The AI of today is not the AI of tomorrow. When AI came out a couple of years ago and we started hearing about this, Um, it the technology was not near as advanced as it is even today. I saw a lot more just random outputs. I could go ask Chat GPT a coding question, and it would give me incorrect responses. And it still does that some today, but the quality and the quality's gotten a lot better, and the error rates with AI have went down dramatically as well, just over the course of 2 years. All right. Now I want to get into some of the core components and technologies, and these are kind of like use cases or places we see AI being used. Uh, First, coding assistants. And when we talk about coding assistants, these are things like Copilot, right? They basically, if I go ahead and start writing code, they auto complete it for me, or they'll suggest code and I approve or I approve it or disapprove it and say I don't want that. But they also do some other things. I can, like I mentioned, when it suggests code, I can either accept them, I can ignore it, or I can partially accept, or I can say, all right, I don't need all of this code, maybe, but some of this makes sense. I can ask it to help me with debugging or refactoring or fixing certain bugs. Or a lot of them now will even explain code to you and let you know what this code's actually doing. However, these products are not really built for test automation scripts. They do require some coding knowledge, right? Now they might support things like writing tests in Selenium, but they're just not special purpose built for it. And then obviously, if I want to have something suggest how to finish my method in some coding language, I need to have started that method and given it some input, and then in order to know whether to approve it or not, I need to have coding knowledge as well. So it definitely is not something just a regular person can come in, or a non-programmer can come in and start generating applications or entire test suites. Next, we're going to talk about test case generators. These are actually something that we hear a lot in the market, and what that means is we're hearing a lot of our customers like that's kind of like their holy grail. They realize AI is getting there, maybe not be there 100% right now, but it's getting there, and that's something a lot of people would really like to see is having the AI pull in data from things like logs, actual user actions. Maybe it has access to my application metrics, my monitoring system results and things like that. It can see how the actual end users are using my application, and things like design documents, the project management system and things like that can actually read it and generate test cases from scratch. It might even be able to take some existing test cases I have written and expand upon that as well. But that would just have a massive time savings implications. Our testers would not have to come in and actually write a whole bunch of test cases for testing different features. When we release a feature, we don't only need to go in there and write a test case to make sure that it works as expected when the user goes in there and so example like a login, right? I probably used the login example a few times during this webinar, but I don't just write a test case. Okay, somebody goes in there, they put their username, password, and click login, and they log in. I also need to write other test cases. What happens if I put an invalid username? What about password complexity? Things like that I need to test alternative use cases and make sure that not only are people able to come in and use it like it's meant to be used, but they can't use it in the wrong manner as well. And this is, like I mentioned, this is a very great goal to have. There are a lot of real world challenges with this. It just tends not to be super accurate. The technology, in my opinion, at least, is just not there to have this really consistent low error rate behavior. What happens is even when we're looking at things like, a requirements document, a lot of times these are written with the assumption that like, hey, this person already has a lot of context. It's a human. They're going to be able to kind of fill in the blanks themselves and figure this out. I'm not going to spell out every little tiny thing in this requirements. We're just going to give a high level. Maybe I just want to put like, add MFA to my workflow. I'm not going to say like what that needs to look like, where it's going to go in the workflow, what kind of MFA it is. Like I'm going to leave that up to the software engineer. So in that case, the AI, it's saying, all right, I've got very high level stuff, but obviously I need to fill in some blanks here. And that's filling in blanks and not giving real detailed instructions where AI does something we call hallucinating, which is it basically tries to fill in the blanks himself. Sometimes it does that really good. It's very, makes sense. Like that's what I would have said as well. And then other times it comes up with something out of thin air that makes absolutely no sense, and it won't work. I've
Hey,
had
Lee,
this problem
sorry.
trying to use AI to generate code. It's there were some gaps in the logic there, and it's making up libraries to import. So it's just
Hey,
it's a
Lee,
very,
just
very great use case. It's just there's still a lot of gaps between this being where it's at right now versus where everyone would like to have. Next, we want to talk about test code generators. This is just when I'm talking about this, I'm saying this is generating test code from a test case. That code could be in any language or framework I want, but obviously there is, the more I let it completely take over without me doing anything and coming in there and checking it, the less accurate it tends to be. So really, it's about finding a balance with a lot of these products between having speed and letting the AI do a lot of the work versus being accurate, having human beings come in here and review the results and make sure that they're actually making sense and meeting the requirements. Another thing I want to point out about these is, at least with the products I'm familiar with, the test code is not in an actual copy paste format that I would use in a framework. I come from an automation background. I have seen hundreds of frameworks over my time in solutions engineering, working with different companies. Everyone I've seen uses some type of reusable methods. So I've got my test code. Maybe it's an end-to-end workflow. I need to break that up into chunks of methods. Those methods need to have variables with arguments. I probably want to take my locators and turn them into variables for a locator bank. A lot of technical stuff needs to happen. I need to have a framework built, right? Even spitting out test code doesn't mean I have a complete project I can just come in there and add it to. So it's even these test code generators require a pretty decent level of coding experience in order to be able to come in and use them. Next, I'm going to talk about NLP test creation. This is a low code, no code approach. So this is actually converting plain language into automated tests. And this is actually a really good approach, in my opinion, because you don't need coding experience, but also as someone that has worked on a lot of frameworks, coming in and trying to figure out what happened with someone's test case, where it's failing at, and then trying to, okay, well, what's this test case doing? What's this code doing? It takes a lot of digging around. Like I mentioned, people use reusable methods and arguments and variables and all these things that make me have to go dig around in 10 different places to actually put together the whole picture. With NLP, it's very straightforward. It just, the natural language tells me it's clicking on an element and it describes the element. It doesn't give me an XPath I have to figure out, or a complicated CSS selector. It's just very easy for anyone to come in and read this. And it's just that syntax and that, the fact that I'm not actually creating code means anyone can just come in and generate tests and debug them. And I can send over a failed test to my developers to take a look at. And, my developers are really good at developing applications. They might not be as, they might not know how to look at an XPath. So they're able to come in there and see like what the name, what elements are being interacted with and where that test is failing. That actually segues a little bit into defining individual steps versus intent-driven testing. So when I say individual steps, I'm talking, click on this link, input this text, hover over this element, scroll the page, select from dropdown, just actions like that. Versus more intent-driven testing. It's like I mentioned, that login workflow, input username in the username field, input password, click on, login. I might just say login as user, and the AI breaks that into steps and then performs the action. And then we talk about, another important feature that, we have in our autonomous product too is the ability to record user actions and convert them to NLP. This actually is a lot different than the old school recording. So I might record something with a, Selenium IDE several years ago. And actually I tried this when I started doing my very initial QA training at my first job as a QA consultant. I would go and perform actions, and it would pick these horrific XPaths that are really long, and it would show me like these crazy locators for the elements on the page. And yeah, it recorded my actions, but it was just difficult to read. It was also very flaky, which meant, when you've got complicated XPaths like that or complicated locators, they just tend to be brittle, and changes made on a different part of the page could just shift around the way the page is built and break those locators. Being able to record those and actually click on a button and have the NLP say, this is that login button. Things like that just make the test a lot more robust and make it a lot more readable. And it also saves a lot of time. To me, I can record that login. I can type in a username, password, and click login faster than I could try to describe it just in pure NLP. So I really think that's a great ability to have when during test creation, and being able to mix the two together really just makes it easy and efficient to get tests authored. Moving on to testing agents. So these are autonomous or semi-autonomous systems that mimic human testing. And really, once we've I always think about it as once we've kind of created that test data, the test, or we have all that stuff plugged in, so it's got all the information to pull in to actually know what to test or do some kind of exploratory testing on its own. To me, the testing agent is really what does the running of the test. It does it gives me a report at the end. It just it takes off and does everything. There are a lot of features that we have baked into things, like self-healing is one of them. So earlier I did mention that XPaths and traditional selectors can be brittle. We much prefer to use a natural language descriptor. Sometimes that's not possible. Sometimes it's just I click on something, there's just, especially with a table, there's just not a good way to explain that natural language. So we might have to use a locator. So what happens if that somebody, changes something else on the page like we discussed, and it kind of changes the page structure of the DOM around? Well, that locator might break, but now with AI, the AI can analyze the locator and then analyze the new page and figure out what the correct alternative locator is and actually fix that test. And like I said, coming from a QA background and doing a lot of automation, I spent a pretty big chunk of time debugging tests and trying to figure out what broke. And half the time it would be locators. So I spent a lot of time, finding new locators that I could have been spending doing, higher value tasks. Exploratory testing is another one. The ability to actually just go through and navigate through my application and just, click on links and check to make sure everything's working okay. Analyzing the pages and things like that are very useful features to have. And that's something that, it's time consuming when people come in there and manually do something like that. And AI powered insights, that could be, I can get AI powered insights from a couple of places. One is just general user information. The AI can kind of take all these different sources that we're giving it and actually spit out insights about how users are using the application or how they expect them to come in and use it. Where particular areas that we need to focus on are and things like that. Getting along to production reality. Once again, things are getting there very quickly. There have been a lot of advances made in the last couple of years. There's still where it requires human oversight. Sometimes these systems just don't 100% all the time work like we expect them to, and it still requires someone to come in and make adjustments. But it's the same benefit we see with a lot of these things. It's not necessarily taking over human, but physicians are like taking humans out of a loop. It's just making us more efficient. It's doing things, and it saves a lot of time if we just need to come in and review results or review where there are gaps instead of having to do everything ourselves from scratch. All right. So talking about the AI actually analyzing that application data and testing results, so it can take that information and forecast failures or high risk areas of applications using all this data analytics. It's just really what used to have been disparate systems, and someone having to go in and spend a lot of time creating reports and dashboards and all that stuff, and the data is still not really connected in a meaningful way. We're having to go and look at some test results and then look at my application metrics and maybe look at some, error reporting and things like that. the AI is actually able to take all that information and put it together and then come up with insights from that and give us really useful analysis and reporting. It can also use that to determine the root cause of test failure. So I mentioned earlier, I spent a decent amount of time debugging failed tests. I would have to go check every test and say, hey, this test failed because this locator changed, or this test failed because actually we put a new field in this form that's mandatory and it wasn't typing it in, or or maybe there is a problem with the application. It called a regression. Maybe there's just something wrong with our testing environment and some of the backend APIs are down. Things like that are time consuming. Now we can use AI analysis to help determine those and to figure out what happened with those test failures. So I don't need to go in and spend near as much time checking everything. I can just go look at the results, and quickly say, okay, it said this. Yeah, that makes sense. Here's, it just really cuts down a lot on that debugging time, which is another big time suck for QA when we could be doing higher value task. And it gives us an overall picture of the health of both the application and the testing suite. I do think this is important. A lot of people think about application health and like how my application's doing. I think sometimes people tend to not think the same way of the testing suite. And really the testing suite is its own application in a lot of ways. It's very important to make sure that my testing suite is healthy, that my test cases are relevant, that I am, being able to detect flaky tests and why those tests are flaky. I'm able to figure out why I have tests that fail frequently. It's just very important to make sure that not just your customer facing or your internal application works, but the actual testing suite itself. Otherwise, an unhealthy testing suite, you're going to have gaps, and you're going to end up having bugs that sneak through. Finally, for the core components, we're going to talk a little bit about the visual AI. I kind of saved the best for last here. So if you're familiar with Autonomous, we've been around for about 12 years now, and we originally were the first in the QA industry really to come out with AI in testing, and we did that for visual testing. And the reason we did that is anyone that's kind of familiar with test automation, if I write a test and I want to verify that some text is on the page, I go, figure out a locator and then say, find this element, get the text, and then I write an assertion. It's time consuming, and that does not tell me that the text is actually displayed correctly on the page. All it does is tell me that text is in HTML. And we have gathered countless examples over the years of we call it GUI gone wrong, but examples of Texas President the DOM that pass a functional test, they pass that Selenium test, they pass that Cypress or that Playwright test, but it doesn't display correctly on the page. And that could be it could be something small that just kind of makes it look bad. It could be something big where it's like I have menu options that are not displaying. Right? Like I can click on the menu options because the element's still there, but the text isn't displaying on it. So your user couldn't use it. So another thing that's come along a lot more in recent years that and AI really comes into use here as well is the fact that we have a lot of dynamic UI environments now. And when I say dynamic UI environments, I'm talking about 10 years ago, I would have users come in on a desktop computer, probably using one of about 3 different browsers. And pretty much if I tested in that desktop resolution, I'm at least in, decent shape. Now we have people coming in and they're coming in on desktop still, they're also coming in on tablets and they're coming in on mobile devices. And because of responsive page design, most applications nowadays are the same app or the same website, same application across all these different environments, and the page is responsive. It adjusts itself to that screen size. So when that happens, something that looks good in desktop, I start shrinking the page. Or maybe all of a sudden I have text that's getting cut off or it's spilling over. Important parts is disappearing off the page. So it's really important to be able to test in a lot of different environments as well. And that's really where the AI can come in and help with interpretate, help detect changes, group like changes together, give you the ability to really make your test robust by doing different types of about, AI visual algorithms mixed in on the same page, being able to do root cause analysis. There's a lot of things where AI can come in there and really just make sure that you're not spending a lot of time manually reviewing your page to make sure that it looks correct. Also, this isn't really AI related. I just like to call it out because it's a great, when we're talking about visual AI and how AI helps you save time in testing, I think this particular functionality is really beneficial too. And it's the DOM snapshot approach versus traditional screenshots. So this is what Applitools does, is we actually capture the DOM of the page, which means we look at the HTML, we get the CSS, and then we get all the assets and resources and basically gather all the blueprint of the page, like what loads up in your computer. But we send it to our servers and we're able to render that across multiple browsers and multiple resolutions. Basically whatever you tell us to, right? Mobile browsers, any resolution you want of any of the desktop browsers, tablets, things like that. And what that does is allow you to run your test one time, and we'll do all that rendering for you. You don't have to write your test to run in all these different browsers. You don't have to write a bunch of code to go in there and resize the browser all the time. Also, since we capture that full page instead of just a screenshot, we can give you the entire page top to bottom, right? In a traditional screenshot, you're coming in and actually capturing the viewport. And then I did kind of skip over some talk about types of tools. This is AI testing. The original thing we're comparing it to is where you take traditional screenshots and it does a pixel by pixel match. And we see this a lot. There's a lot of open source software or some other solutions that provide this. And what they do is give you you take the screenshot, you do a pixel comparison, and I have a number or a little bar I can move, and it says allow 4% variation. Anything more than that, fail it. Anything less than that, it passes. And what happens is you turn that number too low, all of a sudden just regular content rendering a pixel or two off starts flagging the page. You start getting flagged and having to come in and manually review stuff. And if you set that number too high, you could have a settings button disappear off the screen entirely, and it wouldn't flag it because it's not a big settings button. It's under 4% of the UI. So we do think that AI analysis is a huge time saver because of the low number of false positives, and it really catches a lot of UI bugs that either get into production just from lack of testing, or get in because my solution is not very smart and it uses some kind of tolerance setting that doesn't catch. All right. So we'll talk a little bit about production readiness. I know we touched on it for a few of the specific technologies we went through, but just more of an overall thoughts on that. The comparison to traditional and manual and automated testing is pretty obvious. It's way ahead of manual testing. The time savings is tremendous. And even against traditional automated testing, I no longer have to spend a lot of time, digging through HTML, trying to come up with locators and writing code from scratch and all that stuff. AI makes it so I can come in and quickly and easily automate tests that would have taken me 10 times longer to do previously. That's the real pro there, is that's efficiency, right? And scalability. Not only am I able to have one person come in and do that, by making these tools smart and scalable, I can have my entire team, even my manual QAs, I can have the project manager, the business analyst hop in and help, right? It just makes it scalable across the entire organization. And it's cost effective. Open source tools might be, a lot of the test automation, traditional test automation is open source, but it's labor intensive. And overall, my cost ends up being very high. I have people that are spending a lot of time manually testing or automating, writing code for automated tests that I don't need them to focus, or I can have them focus on other things. I can have them, catch things that aren't automatable. There's a lot of use cases that still sneak into production. Just people don't have time to test everything. So it really can make cost effectiveness and just make your overall testing a lot more accurate and reduce the amount of bugs that make it into production. There are some cons to it. We did talk about limitations about the adaptability. It doesn't adapt to change as well. Like I said, when things change or when there's missing data, AI tries to fill in the holes. It will try to do the right thing, but sometimes it's just not smart enough to figure it out, or it hallucinates and it ends up doing something completely unexpected that makes absolutely no sense. And that kind of comes to the human intuition part of it. Those unexpected circumstances, humans are able, we see certain things and we're able to grasp the context of it, or to kind of figure out things on my own. When we when we create applications, or when we create workflows, we want a workflow that a human's going to come in there and it makes sense to humans. Like, humans are going to kind of intuit how they should, perform these actions, and how they should go through the steps. Whereas AI just doesn't have that intuition. All it can do is just kind of base what it does on the data that it's trained with, and that's just not not what's needed all the time. And then complex scenarios kind of go along with some of the adaptability and human intuition. When we get complex scenarios as well, it tries to either freeze up, says I can't do this, or it starts hallucinating and doing unexpected things. So we do see a lot of insights from our customers. Obviously, when we talk about where AI is effectively deployed, we have been effectively deploying AI in visual testing for years. We're also seeing it, very effectively deployed in functional testing now. Companies coming in and doing, natural language and no code type testing, and seeing it perform very well. Where I see it fall short a lot is, to me, the more high level I guess the input is, the more I see it fall short. So the lower level something is, when I say lower level, I mean step-by-step instructions, like click this, perform this action, and so on. It's usually very accurate. When I talk about high level, I'm talking about, I give it like, go buy something and check out with a credit card. And then it's trying to go through this e-commerce workflow with very little information. So it has to like decide, okay, where is this customer? Like, what am I going to put in all these fields for addresses and, payment types, like all what should I buy? Like, there's just a lot of things that are in the air, and the AI will try to fill those in. And sometimes it does perfectly fine. And then other times it's making the wrong decision. So that's really where I kind of see it falling short, I guess, is where you just basically give it little input and it tries to do everything for you. We definitely wanted to leave some time here at the end so you can ask questions if you weren't clear on something, or if you have a different opinion or like me to elaborate on something.
Thanks, Lee. So we have a number of questions here, so we're going to try to get to as many as possible. Let's see. First one is, all right. So you mentioned NLP AI for testing. Could you please expand on this topic and give a few examples of like more than basic scenarios that employ this type of formulation and automation?
So I think this really comes down to NLP steps, and then more like intent-based testing. And intent-based testing is still natural language. It's just, when we talk about intent-based testing, we're talking about higher level. So, the regular easy actions are pretty straightforward, like click, perform these kind of action, do this. We actually get into more complicated scenarios. I was working just yesterday with, trying to locate things on the page using NLP, and there's not a good way to describe it. We were just saying, hey, click on the element below this, and the NLP says, all right, and it goes and performs actions like that. Intent-based testing, I see, I've seen that deployed as well, where we say we're developing that ourselves. It'll be available pretty soon. I don't have dates, but that's currently in development here as well, because we want to make sure it's accurate. That's one thing. We do develop all of our AI in-house as well. So but intent-based testing says that's your more complex scenario. And I don't mean the scenario being complex. I mean the AI performing more complex tasks, which is, I tell it to go verify all the 10 values in this table, and is able to break that down into steps and go perform those actions. All right. Hopefully that answers that question.
Yeah, I think so. Okay, next question. For self-healing, are you using, it should be Selenium or any other machine learning?
Well, Helium's a library you can add to a test, so it heals your Selenium test locators.
Yeah.
Honestly, I can't give you a assurance. I don't think we're using Helium. We are using our own AI self healing in our test. I really don't have the details about um, how that implementation is built. I just kind of know how it works and how to integrate it into test when we when you're integrating into our either our execution cloud platform or our autonomous product.
Yeah, I can say that the execution cloud platform that we're using for Applitools Eyes uses self-healing locators, but within autonomous itself, usually how that works is because the AI is executing based off of the plain English commands rather than locators, it sort of fixes itself as it's going through it.
That's actually fairly accurate with the AI on our no code product. We do use natural language. However, if it is too complicated to describe, we do actually choose a locator in some instances. It's just there's certain situations where you just can't really describe an element with plain language. But if we do use that, that self-healing space is baked in there. So the AI takes a look at the current locator and the current DOM of the page and tries to figure out an alternative locator. And it's actually pretty smart. So,
Yeah.
like I said, I don't think we're using Helium. I'm not sure if we exactly what our backend implementation looks like on
Great. Okay, so next question. Each front-end technology has different DOMs. How are XPaths handled? Svelte is different from React.js, Vue.js, etc. They have lots of shadow DOMs.
that. Really, to go back to what Tim said, we try to handle natural language. So we're hoping you're not actually writing the XPath. If it's at runtime, if we can't figure something out when we're recording, we do choose a locator, and we can uh, select elements in the shadow DOM too. That's a little trickier, but our applications are able to handle that, and our visual AI is able to render shadow DOM as well. So on our visual testing side, it really doesn't matter too much to us. We render it like any other browser would render it. On the test automation or functional automation side of things, we usually just let the AI pick the element based on the description, and the AI is trained with lots of data. We don't use customer data to train our AI, but we have a lot of synthetic data that's trained on it, and it's able to make proper decisions on what locator strategy to use. It on the back end, you're not even customers aren't even exposed to it. You're not going to see it unless it, like we mentioned, falls back on a XPath or something. But it's very stable and just tends to run very well at runtime.
Yeah, XPath is sort of the last resort that
Mhm.
that
Yeah.
autonomous uses there. Yeah, great. All right, for many corporations, there's a huge limitation on sharing stuff with cloud services. How is privacy handled in Applitools, and is there any option of a self-hosted version?
That that is a great question. So earlier in the discussion, when we talked about how I know I mentioned Applitools, we host our own AI. So when you're working with us, you do not have to worry about, hey, I've seen we'll share our SOC 2 Type 2 and like our security certifications and whatever data your security team needs. You don't have to worry about us sending data somewhere else and then having to deal with another vendor. We don't know what's going on with them. We handle data like that internally, and we keep it internal, and we do not use it to train our AIs with. Now, when we start looking at different versions, I guess, of our platform, the two main ones we have are either our public cloud, and when we say public cloud, your data is not shared with everybody else that has login credentials, right? It's your team, your company. You have to log in as a member of your team to be able to see that. It's not just publicly exposed. but it's secured. It's like any other cloud platform where you kind of log in and you see your data, but you don't see the other customers' data. We do also have private tenants available. So we'll give you a private Azure tenant, and it means that's in completely your company's instance of Applitools, either eyes or autonomous. No one else is even like logging into it, right? It's not like it's just a private space inside of a shared tenant. It is a completely separate tenant from the regular autonomous or anyone else's. And then we do have on premises for our ICE product. So our visual testing, we offer on-prem installations of that, and we have several large clients that are using that as well. We have not released that for autonomous. Really, there hasn't been anyone that's demanded it too much. Our private tenant deployment seems to pretty much meet anyone's needs. I mean, at this point, almost everyone's using something that's hosted on the cloud, so there's security approval process in place for that.
How are the sources like logs, user actions, design docs connected to generate the test? Can you demo this with an example, please? We don't have demo up right now, so you can schedule a demo, or I believe Pam has put in a link to a webinar where we previously did some demos with autonomous, so you can look at that. But Lee, do you want to take a swing at the first question here?
Well, we were talking about different types of testing. This is something that we don't have in production yet, so we are working towards that. That, like I said, that's kind of the holy grail, I think, of testing is. But we want to, Applitools, we have been in the AI business for over a decade now. First in the space, really leveraging AI, and we want to make sure we take a measured approach and don't stick out tools that they might look really. I might have a pre-recorded demo video and it looks really cool, but the second you actually try to use it in real life, it's not going to work. We do want to make sure we're actually building stable, usable products, and we haven't got to that point yet.
So how does it test the application against Figma? So I think this is similar to the previous question, but I will say that with Applitools Eyes, if you are a current customer, got a very early version of a Figma integration that you can ask about and see if you can get access to that. It's sort of limited availability right now. As Lee said, we don't want to release anything to GA that's not fully thought out or not fully functional for everyone's case.
To elaborate that a little more, the Figma, we do have, you can use Applitools Eyes for Figma testing right now. It will actually, you can load an image and then you can go ahead and, your image being the Figma mockup, and then we can go ahead and use that same kind of like DOM snapshotting technology we discussed and go through and actually render the actual page in multiple browsers for you and then do a comparison with our visual AI. What happens is a lot of times the Figma mockup and the actual built website are not a pixel match, or even or they have changed. Our AI doesn't actually rely on pixels. It relies on detecting changes a human can detect, right? Like it mimics the human eyes, but we see a lot of the mockups do have changes that between the two that a human can notice. I can look at them side by side and see, okay, these icons are bigger and this is shifted down a little bit, like they're obvious. And we do flag those for you, but like I said, we by flagging those, we say these are the very 90% of this matches exactly. You don't have to worry about anything. And these few spots are where it varies from the Figma. We highlight them where you can come in and look at it and say, okay, this is acceptable. I can deal with this much variation, or this is not. This is too much. We need to send this back and have them make some updates. And that's, like I said, that's available with a current ICE subscription right now.
Right. Great clarification. Okay. Thanks to everyone who joined us today. And of course, thank you, Lee, for an excellent session. If we did not get to your question, don't worry, we've captured all of them and we'll share them with our product specialist to follow up, especially any of the demo questions there. There's also a link where you can set up a quick call to discuss your use case, or on the resources tab there. At Applitools, we understand that AI-powered testing isn't a one-size-fits-all. Whether you're exploring AI-assisted, AI-augmented, or fully automated testing approaches, our intelligent testing platform helps teams integrate AI in a way that enhances efficiency, reliability, and coverage without adding complexity. So if you're already using Applitools, connect with your account team to explore new ways to optimize your testing strategy. And if you're evaluating AI in testing, see how AI-driven solutions can help your team reduce maintenance, scale automation, and improve test accuracy without sacrificing control. And you can start a free trial by clicking on the link below. And again, thank you for joining us. We hope